Welcome to the EuroLEAN Plus lecture series on the design of work cells. This lecture covers how to quantify flow characteristics using the flow dominance measure.
In complicated situations with many parts and many different operation sequences, it can be very helpful to obtain a general idea whether a dominant flow exists or not. And so we can quantify this using the flow dominance measure. The flow dominance measure will start by the total equivalent flow volume that is determined starting with the flow volumes between each item, and obviously this will mean that we will look at operation sequence and also look at the yearly demand, and from that we can determine the flow volume. We also have an equivalence factor that allows us to give more weight to products that, for instance, are bulky or heavy, so the relative cost of moving them will be bigger than that for standard parts, and by multiplying them together we get this equivalent flow volume. Then, using this matrix with the flow volume between each item, we can then calculate a flow dominance measure, which is given by this set of formulas. W is the average flow between each activity pair, so it is given by the sum of all flows divided by the square of the number of items. You can look at f prime as a coefficient of variation of the flow, especially the lengths of the flow, and then this dominance measure is normalized by using an upper and lower bound. Notice that this upper bound is sometimes exceeded when each process does not include all activities. Now, having calculated this dominance measure, we can then look at the value. If it is close to 0, it means that there exist a few dominant flows, because in this case variance is very low, and we can then probably use a product layout, which means that the dominant flow will determine the main layout and also the main cells that we will create. And these quantitative measures will also determine the relationship diagram, which we will use later on. If f is very close to 1, it means that we have many flows and that most of these flows are of equal importance. This means that there is no clear information from the flow alone to determine a good layout, and so we either use all other information that is mostly coded in a qualitative manner within the activity relationship chart, or we can determine any layout which will be equally good. When we are in the middle of the road, it means we have many flows, but none of them is really dominant, and so this presents a fairly complicated situation. In that way, we will have to use all information available to try to come up with a good layout that fits the material flow.
Thank you for watching this video on the flow dominance measure. Please join us in the next video where we will calculate the flow dominance measure in 2 examples. To learn more about other lean techniques for customized manufacturing, please visit EuroLEANplus.org.